Alright, so here we are with the 1-5 notes on solving equations with variables on both sides. And we're talking on both sides of the equal sign. Alright, so our objective, of course, is to solve those. Sounds good. So looking at our first example, here's our equal sign, and so notice that there are variables on both sides. And so we haven't had this yet. You may have been exposed to this, of course, in your previous math courses, but the idea right now is not to just move numbers, but we're actually going to do what I call moving a chunk, okay? So we're going to move, for instance, this chunk of 5n over to this side. So you might think, because it's 5 times n, that wouldn't it be nice to divide? However, that's not actually what we're going to do. It's a positive 5n chunk that I'm moving over to the other side, so I'm actually going to subtract the 5n to be with the 7n. One more thing about what I'm doing here is that I usually pick whichever one is the smallest. So notice I picked 5n to move instead of 7n. So it doesn't matter what side you're moving the things to, as long as, especially when we're working with negatives, if you take the smaller one and move it, it will be easier and you might get more positives. Alright, so then we actually need to take 7n and subtract 5n. And so if you have 7 of something and you take away 5 of that something, you now have 2 of that something left over. From the original equation, we still have a minus 2, an equal sign, and then this over here, positive 5n and negative 5n, will cancel, or become 0 technically, and then your 6 is still left over. So hopefully now that we are at this step, this is what we've been solving all along. So, looking at this next one here, if I have a negative 2 and a 6, I'm going to have to add 2 to both sides. Again, that will cancel the 2's. We'll still have a 2n, or 2 times n, and this is now going to equal 6 plus 2, or 8. And then the last step would take this multiplication and undo it by dividing. And so now we end up with an n of 4. Kind of ran out of room there. Alright, so just in review, when you have variables on both sides, you want to pick the smaller of the variable and move it over to the other side by adding or subtracting. Again, even though you see multiplication going on with that variable, to move, or that first step, is going to be moving that chunk over with the variable and the number. Alright. So the next one here, alright, this is where what I've said before might not help out, because if I take this 3b, which is positive, and move it over to the other side, you end up actually getting, well, 0 on this right side. If I subtract 3b over to this side, we get 0. And so you never actually want to, I mean, you can get 0, but it's a little harder to understand what's happening. So, as much as I said move the smallest variable number with this coefficient, that's what they call the number out front, we're actually going to move the one that is with the number. So, either way, you can actually make a 0, that's totally fine, but it's a little harder to understand. So, I have a positive 4b, and I'm going to subtract 4b, and you can see why I would want to usually move the smaller one, just because now I have a negative 1b. So over here on the right, we have a negative 1b, because 3 minus 4 of something makes negative 1 of that thing. This here becomes 0, so we don't need that anymore, and then we still have our 2. So remember that this is negative 1 times b, so we're going to go ahead and take away, or sorry, divide out that negative 1 times that's being multiplied. So if we divide both sides by negative 1, we're going to end up with negative 2, and then those 1's have canceled, and so negative 2 is your b. And of course you can plug that back in to check, and I do recommend that to make sure that you do actually have the answer. So those are two where there happens to be variables on both sides. And so that is going to be very much like your day 1 assignment, so tomorrow. The next one here, this is more of our day 2 assignment. Okay, and so the only thing that's new is distribution. So again, this is going to, as long as you got what we did in the previous 2 slides, that is what is going to be on your day 1. So this is your day 2 assignment, and so the first thing that we're going to have to do, rather than moving something that has a like term, is actually distribution. So you can see here this -5 is outside of the parentheses and will have to be multiplied into everything inside. So if I take the time to distribute that, I'm going to still have the -1. Notice it was not going to be distributed. And then I will have -5 times 7, which is -35. And then -5 times -2, which is going to be +10. And then the a stays with it. Over on the left side, we have 4 minus 6a plus 4a. All right. And so in our previous combining like terms lesson, we did say that anything that is on one side of the equal sign and then on the other side of the equal sign should be combined first. So for instance, -1 minus 35 can be combined to simplify. And then over on this left side, -6a and 4a can be combined. So the first thing was distribute, if we happen to have any distribution, and then combine like terms. So that's what we're doing here. So I'm going to write that over here, distribute. Alright, and so now we have combining like terms. And so if we have -6 of something and 4 of something, we're going to end up with -2 of that something, so -2a. And that's going to equal -1 minus 35, so in that case -36 plus 10a. And now we are going to be in a position where we were on the slides of the previous examples. So now we're going back to moving the chunk over. So evaluating both of these, there's a number and a variable on both sides. And so we are going to go for the lowest number, which is -2 here, and we're going to undo it by moving it to the other side. So I'm going to undo -2a by adding 2a to both sides. You'll notice that I do write it under the thing that I'm actually going to add it to and not just on the side, so that I do have that visual of where it's actually combining with. So then on the left side here, those cancel and we're left with a 4. Still have a -36. And then now 10a plus 2a becomes +12a. Alright, and now we're back to those original pieces where we're going to add or subtract and then divide. And so if we go through and, let's see, add a 36 to both sides, we end up with 40, and of course these 36s are opposite, so they'll cancel. And that's still equal to the 12a that's over there. And then the last piece that we are going to do is divide both sides, because notice that's multiplying. And so we're going to divide by 12. And we'll end up with our answer that a is equal to. And if you divide that to get your decimal, you are actually going to get 10.3 repeating, or technically 10/3. Oh, sorry, 10.3, no, 3.3. Just very excited about the fractions. 3.3 repeating. So if you are going to have a repeating decimal, you would want to put that little repetin bar over it, meaning that the 3 repeats on forever. And then you could also say that it's 10/3 for the fraction of reducing 40/12. All right. So again, a lot going on in this one. First thing that you're going to look for is any distribution in day 2. So always look for distribution. After that, you're going to combine like terms on that same side of the equal sign. Then you're going to end up moving that chunk. So your third step is to move the variable chunk. And then once you move your variable chunk, then you're going to just have something that you will add or subtract and ultimately divide. All right. Another thing that's going to happen in both of these sets of homework is that you are going to have things called identities. So identities is where an equation becomes true for all values that you could possibly plug in. So very interesting. Basically what happens is that the same thing ends up being set equal to the same thing. So for instance, 2x equals 2x would mean anything that you plug in for x, because of course it would be the same, would end up making the same value. Okay. The interesting part, of course, is that it doesn't look this direct. So instead, you'll kind of have something that's a little bit more fancy, like 2 is also 8/4, right? So instead, you'll have 8/4 x equals 2x, and you'll say, oh, I have no idea what I'm doing there, because I forget that 8/4 is 2. Okay? And again, that happens because you're usually thinking either that math is going to be harder or you're kind of lost in those steps, okay? But it turns out that this is actually the same thing, and so you'll end up having something that's true, a true statement, and therefore you're going to have infinitely many solutions. So you're never actually going to have x equals 1, 2, 3, like you're not going to have to solve that. You're just going to say that the solutions are infinite. All right. If you end up having something that is false in the end, you're going to actually have no solutions. All right, so the big thing here is identifying that if you have a true statement, for instance, you're going to go through and solve, and you're going to get something like 2 equals 2. That means that you actually have infinite solutions. Meaning every single number. If you end up getting something that is false, so for instance 2 equals 0, which it clearly does not, you're going to actually have no solutions. Meaning that absolutely no number could be plugged into there and make it work. So those are your two identities. All right, so here it is, just written out a little bit easier, a little bit more thorough. In your words, when solving an equation, if you get an equation that is always true, meaning 4 equals 4, or in this case, notice here, 3 equals 3, that's going to be, or 2 equals 2, again, that means there's infinitely many solutions. So it's not x equals a number, it's x is infinite. Okay. And then we have our, this one is kind of weird to look at, but it's identities for that one. And then this one is if you have a false equation. So for instance, 1 equals 3 or 0 equals 3. If you are solving those, for instance, notice here x equals x minus 3. Well, that's 1x that you're going to subtract over to the other side. And so you get 0. But then, of course, on the right side, you still have 3. And so 0 equals 3, and now you're scratching your head, but that's because there are actually no solutions that we can find. So we're, of course, going to go through an example to get one of these. So remember our steps. The first thing to do would be to distribute. Notice that there isn't anything to distribute. This is what I wrote on the previous page here. After that, we would combine like terms on the same side of the equation. And then we'd move that chunk if we need to. So, going back to the example we're on, first thing I'm going to do is combine some like terms on the one side of the equation. So let's see, I have a 10 number and a 1 that I could put together on the left side. So I'll actually have 11 minus 5x. And then on the right side, I have a 7 and a negative 12 that could actually go together. And so I end up with negative 5x. Plus 11. All right. Now hopefully you can see, even though I've written them backwards, that these are actually the same thing, right? Both of them have a negative 5x, and both of them have a positive 11. But if you're not looking that hard, because you're just focused on doing the steps, now would be the step of, instead of combining like terms, to move that chunk. So let's go ahead, and again, neither of them is smaller than the other, so I'll just pick one and move the 5x over to be with this 5x. So something's going to happen here that's going to maybe trigger the fact that this is going to be one of those different solutions. And so right now we see that we will in fact have this cancel, and so we'll have 11. And then we see that this is going to cancel because negative 5 and positive 5 cancels. And so we do notice that 11 equals 11. And you're saying, well, this wasn't me checking the solution. But since 11 is equal to 11, that is true. And so x is actually infinite solutions, because you can literally put in any x value, any number for x in all of these, and you will get the same answer. So again, the answer to these problems is not true, all right? It's that x is actually all numbers. So of course, since that one was true, our next example is probably going to be false, but here we go. I don't want to ruin it. All right. So as we did before, the first thing would be to look for distribution. We don't have any right now, but of course in your day 2 assignment, definitely will have that. So instead we combine things that are alike on both sides. So I have a 1x that I'll move to be with the 12x's, meaning there will be 13x's and still a negative 3. And on the right side you have 5x's and positive 8x's, and so together that's going to make 13x's and a minus 4. So hopefully you can see here, again, looking ahead, that these are both the same, but then the number is not, and so that's where that false is going to come in. Either way, you see that this is a positive 13, and so you say, I'm going to subtract 13 from both sides. And so if I subtract 13 from a positive 13, they cancel, and we're left with negative 3. And then over here, if we take a positive and subtract that negative of it, or sorry, subtract its opposite or take away its opposite, we're going to end up with just that number. And so now we notice that this is a false statement. Right? Negative 3 is definitely not equal to negative 4. You could try to add the 4 over, but again, you'd still get two numbers that are trying to be equal that aren't. And so in that case, we're going to have x is no solution. There's literally no number that we know of that we can plug in and actually get a true statement. All right. So that's what you're going to be faced with. Again, you're going to have to solve by distribution on day 2. You're also going to have to combine things on the same side of the equals. And then you're going to have to move that chunk, so that's kind of new, where there's variables on both sides. And then ultimately you might get something where the x's cancel. And so anytime the x's cancel, you're going to look out for that false statement or that true statement. So again, if x's cancel, you will look for true or false statement. All right. So again, those are our notes that we're going to be using for 1-5. And so you will have a 1-5 day 1 assignment, and then the day 1 assignment is just going to be moving your chunks. Oops, I know how to spell chunks. And then your day 2 is going to be distribution and moving chunks, as well as identifying false and negative statements, or false and true statements. Super.